Hi, everybody. Today we're going to start Chapter 7, which deals with nomenclature. So, names and formulas of compounds. Chemistry has a pretty vast vocabulary, and it's almost like learning a new language, learning to name and write the formulas of different things. But this is going to be a super important chapter. We're going to get halfway through Chapter 7 at the break for the semester. We'll pick back up in January, but this is going to be a super important unit because it applies to everything we do for the rest of the year. You need to know how to name and write down chemical formulas because we're going to be doing this all the way up till May. So let's get started. First type of compounds we're going to name, we're going to start simple. We're going to call these binary ionic compounds, or just binary compounds. Bi means two, so these are going to be made of two pieces, a cation and an anion. Remember, the cation is positive and the anion is negative. The way you name them, you name the cation first, followed by the anion's name that ends in IDE. So, for example, NaCl, I know we use this example a lot. It's made of two things, a cation and an anion. You would name it sodium for the cation, chloride. You have to add the IDE to the end of the anion. Another example, if I said potassium oxide, and I wanted you to write the formula, you'd need to know the charges. So potassium's symbol is a K, +1. Oxygen is O, it's a -2. So you have to think to yourself, okay, if these two are going to form a compound, what's that formula going to be? We're trying to even out the charges. So you should be able to figure out that it's going to take two of the potassiums to cancel out the charge of the oxygen. So you get the formula K2O. Other examples, if you were going to make a compound out of magnesium and phosphorus, what would its symbol be and what would its name be? Well, magnesium symbol is Mg and it's a 2+ cation. Phosphorus, its symbol is a P, it's a 3- anion. So what do they have in common? How can we cancel these out? Well, I think it's called least common multiple is 6. So if you go to +6 and -6, you'd have 3 magnesiums and 2 phosphorus. Another kind of a trick to this, you can take what their charges are and write them as, we call these subscripts, Mg3P2. And you can see that if you had 3 magnesiums, you'd have a total of +6. And if you had 2 phosphorus, you'd have a total of -6. So they cancel out. So there's your formula. This would be called magnesium phosphide, ID. Next up, after binary ionic compounds, we're going to talk about ionic compounds that need Roman numerals. So you've probably noticed up to this point in the year, we've kind of ignored the middle D block of the periodic table. We've kind of skipped over them. That's because some of those elements, some of the transition elements, can have more than one positive charge, more than one different charge. For example, in nature, copper can be found as either +1 or +2. Another example, lead, Pb, can be found as either 2+ or 4+. And there are lots of examples like this, all from those transition metals. And so we have to specify the charge, kind of the key to this section. We specify the charge of the transition metal with a Roman numeral. Let me show you what I mean. If I had the compound CuCl2, I can't just call it copper chloride because, again, copper could be a +1 or a +2. We have to be specific. So I need to figure out what the charge of this copper is. So if I drew a picture of copper chloride, I'd have a copper ion, and I have 2 chloride ions. Well, we know the charge of chloride is -1, halogen. So what does that mean that charge of the copper has to be? Well, it must be a +2 to cancel out the 2 chlorines. So in parentheses, I put the Roman numeral 2. That tells me the charge of the copper. Another example, if I had MnO2, I can't just say it's manganese oxide. Because manganese is a transition metal, it's in the D block, it might have more than one charge. So again, I draw a picture. Here's manganese. It's connected to or bonded to 2 oxygens. We know each oxygen is 2 minus. So what does that manganese have to be? 4 plus. So it's manganese 4 oxide. One last example. Go the other direction this time. This one's going to get a little ugly. FeO. Sorry, gave that one away. We're not going to go the opposite direction. We're going to keep going the same direction. FeO, and we want to name this. We've got iron something oxide. What's the charge on the iron? Well, you've got 1 iron for every 1 oxygen. Oxygen is 2 minus. The iron must be +2. So it's iron 2 oxide. Just for good measure, let's do one more. I'll give you the compound cobalt 3 phosphide. So we know cobalt is going to have a 3 plus charge, what the Roman numeral tells us. It's bonded to phosphorus. Phosphorus is a 3 minus. So you need 1 of each. CO. Notice you do not have CO3E3. You always reduce if you can. Instead of both of those having 3 subscripts, they both just need to be 1 subscript. You need 1 plus 3 and 1 minus 3 to cancel out. Last but not least, let's talk about naming compounds with polyatomic ions. Polyatomic ions, we've drawn Lewis structures for them before. These are things like NO3 minus, CO3 2 minus, CO4 3 minus. They're groups of atoms that are covalently bonded together that have a charge overall. They stick together. These elements are not going to come apart. And they bond as a unit. And they have names. NO3 minus, for example, is nitrate. CO3 2 minus, carbonate. CO4 3 minus, phosphate. There are lots of polyatomic ions you're going to need to learn the names of. There's a table in your homework packet on page 2 with some common polyatomic ions that you're going to need to familiarize yourself with. Also on the back of the periodic tables that I gave you all, there's a table of polyatomic ions. You're going to need to know a lot of those too. You're going to use them a lot, so you might as well start committing some of the more popular ones to memory. So for example, if I wanted to write the name of NaNO3, it's simply sodium nitrate. Sodium is the cation, nitrate's the anion. Another example, if I wanted to do iron 3 sulfate, well, iron is going to have a 3 plus charge. Sulfate is SO4 2 minus. So our common least common multiple here, our greatest common factor, I never know if it's greatest common factor or least common multiple, neither here nor there. It's 6. Okay, if we have 2 irons and 3 sulfates, we've got 6 pluses and 6 minuses. So Fe2 SO4 3. Except I can't just have the 3 next to the 4 because now it looks like there's 43 oxygens. So what we do is we put the sulfate in parentheses. Last couple things just to clean some things up, things I forgot as I was going through and I just remembered. Roman numerals, there are a few ions that always have the same charge. Just write these at the bottom. Silver is always +1. Zinc is always +2. They come up a lot. You don't need to use a Roman numeral because silver is always going to be a +1. Same thing with zinc. You don't need to use a Roman numeral. So AgNO3, for example, is just silver nitrate. You don't have to say silver 1 nitrate. It's redundant. Silver is only ever +1. Hopefully this helps you do your homework tonight, pages 1 and 2 of the packet. Come back on Thursday ready to ask questions and go over the answers. Thanks.